Good evening. In chapters 10 and 11, we're going to finish up our study of ecosystems by looking at how ecosystems recycle two very important components for the maintenance of the ecosystem, specifically water and soil. We'll begin our discussion by looking at the issue of water. Typically, we really don't think about water as being something that's a precious resource, particularly here in the United States where we have abundant water. And given the fact that the earth is covered two-thirds with water, we again don't necessarily think of it as being something in short supply. But most of the world's water is salt water, 97.5%. And salt water typically is not only not useful, but can actually be harmful to living things. The only useful water for maintaining ecosystems and life is fresh water. And of all the water in the world, only about 2.5% is fresh water. And of that fresh water, the majority of it, 1.7% of the 2.5%, is tied up in the polar ice caps and various glaciers. Less than 1% of the world's water is available as accessible fresh water that can be used for the purposes of maintaining life. Earlier in the course, we saw how ecosystems recycle important elements, notably carbon, phosphorus, and nitrogen. However, ecosystems can also recycle important compounds, that is, materials made of more than one element, most notably in this case, water, or H2O. We'll begin looking at the recycling of water through the process called the hydrologic cycle by looking at where it begins, if you will, in the atmosphere. Water in the atmosphere is in the form of clouds, and clouds under the right conditions can be induced to liberate that water in the form of precipitation or rain. The rain, when it falls, has a number of different options, one of which is it can roll off the surface of the ground that it strikes and into open bodies of water, or it can be absorbed by the ground and become part of the groundwater or water table of the land, and in some cases find its way back into open water. Or it can be held by the land until such time as green plants can soak the water up through their roots and into the tree, where it can be combined with carbon dioxide to produce glucose through the process of photosynthesis. The tree then and other photosynthetic plants utilize that glucose through the process of respiration, and as one of the byproducts of that respiration, gives off water again through a process called transpiration back into the atmosphere. Water can not only be returned to the atmosphere, water can be returned to the atmosphere by the process of evaporation from large open bodies of water such as lakes, streams, and oceans, and in so doing, return that water back to the air as water vapor, where it becomes again part of the cloud system, which can then generate rain and start the cycle again. So this way we see a number of different ways in which water passes from its liquid form as rain to its vapor form known as water vapor, and in the process of cycling become useful for photosynthesis by green plants, and thus contribute to the making of glucose and organic compounds that become the food for all other living things in the ecosystem. However, not all water in an ecosystem necessarily gets recycled. Some of the water, that which percolates into the ground, sometimes is not able to be recycled because it does not make its way back to an open water system where it can evaporate back into the atmosphere. This water that's lost to the ground is referred to as consumptive usage. It's typical of what we do with water when we use it for the purposes of irrigation and other kinds of uses in which water falls on ground and is not able to be retrieved. This consumptive use of water is an issue because of the fact that when it is lost from the hydrologic cycle, it is essentially lost to use by mankind. And it's one of the reasons that drives why we have to be careful of preserving our precious freshwater resources. One of the main suppliers of fresh water in the United States, besides the Great Lakes and some other open lake systems within the United States, is something known as the Ogallala Aquifer, which is shown here in this pink. The Ogallala Aquifer refers to underground water that exists in the central United States. This water is accessed by drilling pipes down to that water and drawing it up for the purposes of irrigation. It's one of the reasons why the Midwestern United States is one of the most productive growing regions in the entire world. But this particular water is also known as fossil water. And that's because this water was formed many millions of years ago during prehistoric times as a result of a prehistoric lake that once occupied the center of the United States. This is a limited supply of water, and when it is used up, there will be no more, simply because there isn't a geological time period in which to recreate it. So water is a precious resource, fresh water, because of the limited supplies that we have. And for that reason, we need to be able to better manage and conserve it. Since we can't create water, at least not in the volumes that we would need to sustain life on the entire planet, it's necessary that we find ways to better conserve the water that we have and more productively utilize the water that's available to us. One of the principal losses of water occurs through irrigation. Irrigation, when done irresponsibly, can lead to drastic water loss. In fact, the beginning of this chapter notes what happens to the Aral Sea, which you can see in the photographs we have here. In the case of the Aral Sea, which exists in Russia, farmers tapped water that feeds into the sea through various rivers, tap the water off those rivers to fertilize their soil so that they could grow cotton. But unfortunately, they tapped off so much water for purposes of irrigation that there was very little or no water flowing into the Aral Sea itself. And as a result, as you can see from these photographs, in less than about 20 years, this entire sea basically evaporated down to two relatively small lakes, which are so salty because they're so concentrated that they won't support any kind of life at all. So we need to use new technologies to more responsibly and more efficiently irrigate land, and we're also looking at new technologies to more efficiently and economically process salt out of salt water so that we can use it for municipalities and for cities and other types of irrigation that depend upon fresh water. That brings us to the issue of soil. Typically, we don't think about dirt as being anything very important. But when you think about it, if it weren't for dirt, there would be nothing for plants to grow in and from which to retrieve the resources and all the other materials that they need in order to undergo photosynthesis. And without green plants and photosynthesis, there'd be no food. As it turns out, soil is not a simple, basic thing. Soil is, in fact, a rather complex community of living and non-living constituents that all depend upon each other in order to properly function. Without organic decaying matter from dying trees and plants and animals being decomposed by decomposers in the trophic levels that we looked at, and being mixed up within the soil with the inorganic materials provided by the minerals in that soil, you would not have the proper components in order to sustain plant life and photosynthesis. Soil, like water, can actually be used up. That is, we can deplete from the soil the important nutrients necessary for growth and leave behind dirt that is incapable of sustaining life. What we see here is the effect of what is called salinization, that is, watering land with salt water. Salt water degrades the soil and because of the salt actually makes it hostile to life itself. Other ways in which soil can be degraded is through erosion, both wind and water erosion. In that case, the soils are actually washed away or blown away as a result of environmental issues, and you can end up with soil that is incapable of supporting life, such as what happened to the Easter Islanders. So it is important that soil, like water, be treated well and conserved well, and that best practices be used in terms of using that soil and assuring that the proper nutrients in the soil can be recycled for the benefit of growing yet more plants to sustain life. Finally, in Chapter 11, we're going to look at some techniques for minimizing the loss of soil or the degradation of soil and other types of soil conservation techniques. Such techniques as rotating crops, contour plowing, of which we see an example here, where the rows for planting crops are done perpendicular to a hillside so as to minimize the rate at which water flows down the hill. We're also going to look at windbreaks, which are trees that are planted in order to help minimize the amount of erosion due to wind blowing over the soil. So as a result, with this chapter we see that soil is a rather complex ecosystem in and of itself that is made up of many biotic and abiotic factors which all must work together in order to provide the appropriate mix of nutrients to sustain life, and that in fact soil has to be recycled in much the same way that other important commodities such as water and carbon and nitrogen and phosphorus are. And perhaps after these two chapters you'll never quite look at soil and water again as being essentially worthless.